Hello, my name is Pawlenko. My co-presenter is Charles Pooh. We are developers at Wolfram Research, and our presentation is entitled Connecting to the Wolfram Computational Geometry Engine. Wolfram Engine connects to a lot right now, and that's one of the things that we're really going to focus on is the extent that we connect to now. And when I say we connect to something, what I'm saying is they have an interface that we also implement, and we can establish communication to do things. Later in this presentation, I'm going to show you a specific example of that in an application called Blender. And we're going to show you how Mathematica out of the box can communicate with Blender out of the box. Just a couple minutes. First, we're going to talk about the how this occurs and all the different ways that we can communicate. Why we use different ones for different reasons, for example. So what we have is evaluating external languages like Python, Node.js, Julia, and what we can do is basically evaluate external function calls, passing simple parameters, integers, strings, things of that nature. Reasonably low level, not a lot of structure in the data. Running arbitrary processes, starting processes, running processes to obtain process level parallelism, application level parallelism, essentially, on most modern CPUs. Generating code to call Wolfram Language functions, embedded code. And a lot of your modern web languages support embedded code. And then C, C++, Java, .NET, Python, and this group right here basically encompasses a vast array of modern applications. Most modern applications implement one of these, one or more of these. And almost every modern application that does anything, a serious modern application, implement something here to be able to right now connect to Wolfram Engine. So our import and export formats, just an overwhelming variety and different categories within that variety of file import exports within these certain formats. Web deployment, cloud deployment, network programming, socket connect, real low level, general programming, and that we'll actually implement this in call to Blender. So those are just a real quick look at some of the ways that we do connect to applications now. So we're going to zoom in on one of those and take a closer look, and that's Python. So basically the point is that any digital content creator, DCC, that implements Python can interface with the Wolfram Engine now. And we're going to show an example of exactly that. But before we do, we want to talk about tighter integration. So this is where we kind of bring it together. And the example that we're going to use is Unity Link. And Unity Link integrates Wolfram Engine more tightly with Unity. We basically connect to virtually everything now, including Unity. But what Unity Link does is it provides a tighter integration. So let's go ahead and take a look at the Unity Link page, and we're gonna go and talk about the basics over here. But before we do, this is a lot more familiar to a lot of people, particularly people who have a Mathematica background. Exported graphics is really what I want to point to. Anyone who's ever programmed any reasonable amount in Mathematica understands that graphics and graphics object can be arbitrarily complex. Okay, so there's a lot of structure. That's not just a simple integer array or a string. There's a lot of structure involved in moving that. So that's one of the things I wanted to point out, just because it's such an easy example to understand. So let's look a little closer at Unity Link, and what we can see is we see low level to high level, all the way to scene, and then a game object. And what's a game object? It's a collection of components, audio source, transform, a mesh renderer. Okay, and a mesh is basically anything that's rendered in a 3D scene. For our sake and purposes right now. Lights, cameras, mesh filters, basically everything you need to render a 3D model, and then take a collection of 3D models and render them into a scene, as people would do, typically want to do in Unity. And so we provide the mechanisms to seamlessly do things at that high level with Unity Link. So that shows you that we're taking low-level calls and we're building them into things that are more substantive, that give higher level control and are much more tightly integrated. So let's go ahead and take a look at something that we can connect to now and are going to, and that's Blender. And Blender is a popular DCC, digital content creator, used to create 3D models, photorealistic images, movies, and more. So let's go ahead and take a look at Blender website. And you can go to one, it's free to download. You can go to Blender website, download Blender, and the Blender I'm using is just a regular download. You can see about the cycles rendering engine. You can see the kind of images that it generates, scripting, UV, textures, VFX, integrating with video and 3D models, animation, rigging, story art, 2D, 3D, all kinds of stuff. And this is really kind of brings us full circle, make your own, where Blender has a flexible Python controlled interface. And so we say, well, if it has a Python interface, we should be able to integrate with it. So let's show that we can. And what we have is Blender right out of the box. Nothing added. Straight into the scripting language, and we'll open up a new script, and now we're just going to paste something in there. So I'm going to go over here, and we previously prepared some Python. Make sure we get the right file. And we're just going to select it all, copy it right over here into Blender. Come up here and run it. Open up Mathematica in 12.1. Make the socket connect call that I was telling you about, and it connects because Blender's waiting for it. And now we're gonna send this string over, and this program is going to add a cube over there. And there it is. And then it's gonna do no command to show that it recognizes that it's no command. We're gonna send an axis, and it sends the axis over there, and we're gonna quit. And we just control Blender through Mathematica. And notice this can be anything. This exposes the entirety of the Blender API. So this is a simple contrived example, but it could be anything. One other thing I do want to show is another simple example, but kind of to the point of extending their GUI. Also, while we're here, just as easy, another program, Python program, select the whole thing, copy, bring it over here, remove the existing program, and paste the new one in, and then run it. And look, you see item tool view, and now you're going to see another tab get added. And it's the Mathematica tab, and now we have our own tab, and kind of brought a full circle where we can connect the buttons to the functionality. So it's basically what we wanted to show, how easy this is to do all these things. So really this is the message that we're trying to depict, is connect between the Wolfram engine and the digital content creators. We got Maya, Unity, Blender, we already talked about, Houdini, 3D Max, and we can connect to them through a variety of application interfaces right now, just like we did with Blender. In the future, we want to make things more like Unity Link, so we can make things easier for the people who are trying to use our software to help in their workflow and to do the things at a higher level that they're looking to do. So that's the direction that we're looking to go. That's the vision. That's the presentation, and I hope you enjoyed it. Hope it was informative, and thank you very much for listening.
Feel free to turn on your microphone if you have any question. So I'm here, I'm Charles, and Paul is also here to answer any of your questions.
Hello?
Hello.
Is it the two of us?
Charles is here.
Hi,
Hello.
Nicholas. Hi.
I had a question about either exporting or print out 3D to stereolithography. Is this the right place to be asking the question?
Yes, definitely, it's the right place. Yes.
Okay. So if I, using 12.1, I create a solid that's a combination of cubes and spheres, and those render fine. But then I add an ellipsoid under them, and then essentially they all sit on the tubes and spheres. And as soon as I add the ellipsoid, the rendering fails. So they gave me I posted this on Stack Exchange, and they gave me a workaround, and the workaround works only for ellipsoids. It doesn't work for prisms, but essentially, if I let me open our link in Zoom so I can give you the link. How do I just switch to Zoom? Oh, here it is. I have a button for Zoom. Hold on. I don't know. Maybe I'll go away. I'll be back on Zoom. Hold on.
I typed a couple questions into the chat there. It's under Michael Trott there. So concerning the Blender call, it was interesting there. Can you go the other way? Can you have Blender call Wolfram?
Yes. So the plan is to build a bidirectional link, right? So that essentially, if you are a Wolfram user, more familiar with Wolfram, you can use Blender and all the advantages which come with Blender. But on the other side, if you are, a Blender user and you just want to use some functionality in the Wolfram language, you should be just, from Blender, just call the Wolfram language. For example, you can generate the geometry or do some, manipulation on your scene, right, directly from the Wolfram language. And I believe during the presentation, Paul actually shows that, and it will be kind of model based on the, the Unity link. So it's a pure directional, bidirectional link and a live link actually between both systems. So what we hope is essentially, if you're a Blender user, and you are Blender interface and editor, you can just use the Wolfram engine behind like a plugin, pretty much. I hope that answers your question.
Yep. Also, a more technical question is, what about using Godot instead of Unity? I don't know if that means anything to you guys, but.
I'm not familiar with Godot. What is it? A game engine? Is it a
basically, I think the problem with Unity is it has some interesting licensing things that makes it a little bit awkward to use. But Godot is more of it's a more open system than Unity, but it also works in Blender.
Well, it doesn't work in Blender.
Oh.
They play nicely together.
They play nicely together. Sorry, I'm translating for my wife, who is a big Blender user. So.
Oh, okay. Well, we'll take a look at it, and I'm not familiar with that, and I'm sure we can probably, Jeff, later on, sit and look more in details.
Right. I might have to have some pre-scripted questions because, like I said, I'm kind of a middleman here. So.
That's perfect. As long as we get all the question and feedback from the expert,
right.
if you Blender user, that would be great.
Right. Thanks.
Welcome. And Nicholas had the question he actually sent on the chat there, which was the link. And I think his original question was essentially trying to export to use 3D print. print out 3D function to generate, STL or directly from our geometry. So essentially, he was using cube. From what I read from Stack Exchange, and when he had an ellipsoid, he have issues. I am not sure I understand the issue from the Stack Exchange post, but I will just kind of talk more in general on the pipeline. So in principle, when you have graphics, right, like tube, ellipsoid, which are all kind of roughly quadratic surfaces, right? SDLs just support polygon. So what we do behind the scene is first to discretize them. So we roughly approximate them with polygonal surfaces, with polygons. So we get the polygonal surfaces and export them. So the only time where that the issue can happen is during that conversion, right? And what we also try to do is that, right? So when you have a scene and you have different objects in the scene, so we are not really sure that you are exporting your function. Your scene when you are exporting it, we don't really know how what you are going to do after. So in between, we try to do some Boolean operation to essentially handle a high quality mesh region at the end. And that also may be the issue, especially that for 3D printing, you don't actually really need to do the Boolean operation. Usually it's a union when you have a big scene, right? You don't really need to actually join all the elements all together, right? And do the Boolean operation before you send it to the 3D printer, because the slicer will actually take care of it. So what I will suggest in your case is that when you have an issue like that, you should just discretize all the elements, have them in the graphic, and then use export directly. So through that pipeline, we're actually going to avoid doing a Boolean operation, and you should be able to actually always get your object correctly. So the geometry will have overlapping polygons, and your slicer for your 3D printer will take care of it, because it doesn't really matter for it when it slides the geometric object if there is self-intersection. And it should actually work in principle. So I hope that kind of give you an idea of where the issue may happen and what how to work around it. And Nicholas, you're actually here. I hope that answers your question. So feel free to.
Yeah, it answers the question. It gives me the workaround for the ellipsoid, adding the ellipsoid, but it doesn't. I don't think it gives me the answer for the prisms, which doesn't matter because I was trying to substitute the prisms for the ellipsoid in case I could print out 3D the prisms. But exporting the graphic with the ellipsoid is fine. With the ellipsoid is fine. But just looking forward, I suppose my advice would be that I don't understand why I should have to discretize the graphics before exporting them and 3D printing them.
Right.
Yeah.
So in principle, the prism should work, right? If there is an issue, send me that. I mean, that one should be a trivial case. I was explaining why we need to discretize it, because an ellipsoid, right, is a quadratic surface, is a smooth surface, right? In principle, you cannot actually represent it, preserve the fidelity by representing it as an STL file, because STL just represent polygons. You see, so what we do is that we need to approximate that surface with polygons.
Right, but then the prism should it be easy to represent, because the prism is polygons, right?
Exactly. So that's why that one I'm pretty much convinced that it should work automatically. If it doesn't work, that means it's a bug, and it is, it'd be surprising that there is such a bug, because Prism is just purely a linear cell, so that should be trivial.
Yeah.
Yeah. So just if you have any issue, feel free to send me an email, charlesp@wolfram.com, and we can take a look at it and try to suggest a workaround, or hopefully things will work easier for you.
Yes, thank you.
Well, if there is not, if there's no any other question, it's already 11. We are going to close this talk. Thank you for attending and watching the video.